Hey, Ian here. So I was watching a video not too long ago from Alex Hermosi, and he was talking about he wished he documented more of the process of his come up into, becoming a successful entrepreneur. And he mentioned how cool would it be if there was like a daily vlog or a weekly vlog when Elon Musk was getting started, or Jeff Bezos or Richard Branson. So since those are the kind of people I'm aspiring to be right now, I thought it would be cool to document the process I'm working on. So right now, what I'm doing is I'm applying for NASA grants. I have kind of like two ways, or three ways I'm trying to generate income. So that's from the main business, the Lucid Dreaming business, and it's also incorporating manifestation into that. And then I am seeking funding for that lucid dreaming business, which is called through what's called a convertible bridge, which is basically like a convertible bridge loan, which is basically like a business loan. I'm looking for about 500K so I can hire several employees to help me out, because right now it's basically a one-man show with some subcontractors here and there. And what that will do is for the investor, it's a loan I'm taking against them, so I pay them interest, and then if I end up raising money in a Series A round, they get preferred stock, at a discounted price. So that's why it's ideal for them. And then the third way is for the other business I'm working on. I'm kind of working on two side by side. One is the lucid dreaming manifestation, and one is space related. I'm really interested in electric propulsion, and kind of my long-term vision is revolutionizing civilian space travel, where everyone could, theoretically get to low Earth orbit as cheaply as it is currently to own a car and go to the grocery store. So, since my main focus, the lucid dreaming and manifestation, I'm putting about 40 hours on each of these businesses a week. So it's like two full-time jobs, and the goal is to generate income and get sufficient funding to develop out the prototypes for the electric propulsion. So for funding for the electric propulsion, I was looking into NASA. And for those of you who don't know, NASA offers grants and funding without requiring equity from the company. So right now they're offering what's called the SBIR Ignite program, and it's 150K for 6 months worth of work. And this is phase one, and that's to prove out the concept of your technology. And then they also offer phase two at, I believe it's 850K, and that's for up to 24 months max. And what that would do is, without diluting any shares in my company, I could build out the propulsion device with an onboard motor, in phase one, and then phase two, the 850K would be enough to actually create a EVA spacesuit. So EVA is extravehicular activity. So basically a spacesuit that can function outside of the spacecraft. And what my ultimate vision for this is having the spacesuit with the attached propulsion device. So where the whole spacesuit is a capacitor metal spacesuit. So what this would do is, since the propulsion is what's called asymmetric capacitors with pulsed high voltage. And these designs are based on early Nikola Tesla work, and also T. Townsend Brown. There's a few others where I spent the past few years just studying this technology, so I can develop it for commercial use. So basically it functions by creating pulsed high voltage in the asymmetric capacitor, which is basically like a easy reference is like an ice cream cone, and where it's long and flat on one side, and short and sharp on the other. And when the current passes up that and goes from the flat to the short side, it generates a propulsive force that actually functions both in Earth's atmosphere and in the vacuum of space. So if you can integrate that technology and generate enough lift from it, you could actually have a spacesuit that could function in the Earth's atmosphere and the vacuum of space. So you could, order a custom metal spacesuit and be able to start off on Earth's surface, go to low Earth orbit, and come back again without a rocket needed. So that would kind of like be the next breakthrough for civilian space travel, and it would make access to space much cheaper for NASA. So that's why I think they'd be interested in this project and fund this business. So the kind of process I'm looking at, if I can add this over here. So I created a checklist of everything I need to make this happen. So 2 3D printers, 2 Palette Pros, which are basically, it's a machine that lets you attach to a 3D printer and print multi-materials at the same time. So you can actually create the entire propulsion device from one print. And then a kiln, because it's going to be printing metal filament. So what metal filament is, it's a metal powder with PLA plastic combined together. And then you put it in a kiln to melt off the PLA and to heat up the metal so it bonds together. And then it's a completely metal part. So you end up being able to create metal prototypes much cheaper and much faster because, depending on the size, you could turn around an idea design to fully functional prototype in as little as 3 to 7 days, from the printing time, 1 to 3 days, the kiln time, 1 to 3 days, and assembly. So that's kind of where I'm focusing the funding goals on it, because how NASA works is they want you to break down specifically each amount that you're going to use. It's very similar to fundraising outside to angel investors, where they want to know specifically what you're going to use the money for. So I'm also going to be getting 2 filament makers, because there are some filaments that you can already order, like stainless steel, aluminum, copper, titanium, tungsten, things that are already made, but there's certain materials that I'm going to have to make personally, because the power structure, some of it involves crystalline power, so power cells, which is made up of a quartz crystal composite. So having that specific mixture mixed with PLA so it can print through a normal 3D printer and then be put through a kiln so it works properly, that's why we'll need filament makers to get that right setting out. And then the filament itself, I set aside $30,000 for that. This allows, depending on the size of the prototype, 10 to 30 iterations over the course of 6 months. So that way we can have sufficient testing. And then the rest of the money, which is actually a large portion of it, goes to the salaries for the engineers. So having 3 3D printing engineers, one focused on the design, one focused on the printing, and one focused on the washing and sintering of the parts. And having those 3 specializations. And then there's me, the business lead, and kind of like the focus on the electric propulsion. And then I also have my grandfather working on this, who's a mechanical engineer. He actually got his master's in MIT. And he's worked on, he even worked on the Gemini program. For those of you who don't know, it's like the precursor to the Apollo program. He's been around the block. He just recently turned 93, so he has a lot of insight in this type of field and technology, and he kind of inspired me to reach out to NASA, and that's how I initially found these funding grants. So yeah, that's what I'm working on right now. I just wanted to give an update. So I kind of did the initial setup process. There's actually a lot of registration you have to do to qualify for these government grants. You have to have an LLC set up, and you have to link it to all your accounts. So it's quite a lengthy process. They give about 1 to 2 months during certain solicitation periods where you can actually submit proposals. So right now what I'm doing is I'm working on the slide deck and the white paper. So the equivalent for that for investors, you call it a pitch deck, where it's a series of 7 to 15 slides of what your technology is, how are you using it, what you're creating. And then the white papers, if you're doing something technical, it's specifically laying out how this technology works, what's proof that it's worked previously, what are tests other people have done, what tests have you done, things of that nature. So I'm going to be working on that now. I might not record that. It might seem tedious, so I might pause this here and then come back when I finish it. But I thought I want to start creating updates. One, to just log this information so I can look back on it in the future and see where I started and where I got to. And two, if anyone else gets inspired by this and wants to do similar things, go for it. Yeah, then I guess the next video will be when I finish either the slide deck or white paper. I'll kind of walk through that process. And when I get better at this and more funding, I'll get a videographer editor to make these videos a little bit more professional. But until then, enjoy it. All right, that's it for now. See you later.